So last time we talked about bagging and we talked about tree models. Now we're going to talk about boosting. The idea of bagging is you combine one model with many different types of data from your data set. The idea of boosting is you have many models to build a stronger ensemble model. Each model focuses on the error made by previous ones, and together the models learn by correcting each other. They use a weighted majority vote for classification, and they take a weighted average for regression. So here's some data from two different classes, the blue class and the red class. As you can see, this classifier blue doesn't do so well. This classifier blue doesn't do so well, and this classifier blue doesn't do so well. You have a lot of blues here, but you have these blues here. You have these reds here, but you have these reds here. And then if you combine all three classifiers, you perfectly classify. So boosting models are built sequentially, learning from the models of the previous errors, whereas bagging models are built independently using random samples of data. So there's boosting, parallel, bagging, sequential. So AdaBoost is a popular algorithm for boosting. You start with n samples, you assign equal weights, and then for m rounds, you train the classifier on the weighted data. You compute the weighted error, you compute the model weight, and you update the sample weights. And then the final prediction is the sign of the sum of your models. So if you have a data set with two features and binary labels like we just showed, each point has two features and a label. AdaBoost will feed weak classifiers, and then over multiple rounds, we'll learn more and more effective splits. So here, take a moment and think about where you would split this data. One option would be, we're trying to separate blue from red. So one option would be to go like this, and everything here is blue, but then you have these two reds. So epsilon is the weighted error of the rate of the weak classifiers around t. Alpha t is the weight assigned to the weak classifiers around t. Z is the normalization factor, and d of t is the weight of the sample after round t. So you start off with drawing this line here. Everything above here is classified as blue, and then you start off drawing a line here. Everything here is classified as blue. Everything here is classified as red. And then you do another one here. And this side is classified as blue, red. And then you end up with a boundary that only is classified as a single point. So you're combining weak rules into a strong prediction by weighting and correcting errors. So just to recall, a decision tree is a single model that splits data by simple rules. A random forest builds many trees on random samples and averages the results. And boosting builds models one after another, each correcting the last, focusing on the hard cases, improving in performance. Trees are simple but weak. Forests reduce variance but also increase bias. Boosting reduces biases. Together, they're building more complex models from simple ones. Thank you.